Today we are Today we are going to learn how selection sort work. Suppose this input is given and these are the index 1, 2, 3, 4, 5, 6, 7. So total 7 elements are there. So what we do in selection sort? First of all, this is in place and stable algo. This is in place and stable algo. And what we do in it? First we select first smallest element and we put it at the first place. So there are n minus 1 passes total, because total n elements are there. So n minus 1 passes. So pass 1, what we are doing, suppose we are starting from I is equal to 1 and we are supposing minimum element as 1. We are supposing that at first position we have minimum element. After that we are doing comparison. So first we are comparing first element with the second element. Yes, first element is greater and second element is less. So instead of first we take second. Then we compare second element with third. No, it is not less, it is greater. Then we compare second element with fourth element. Yes, it is less. So instead of second, fourth element will come. Then from fourth to fifth, fifth is greater, so no swapping. Then 4 to 6, this is greater than 4 to 7, this is smallest, so 7th. Then what we will do, we will swap the first position with this element. So one swap. So now what will be the array? 5, 24, 41, 15, 82, 91 and 75. Instead of 75, 5 will come. So this is the swapping. So 1, 2, 3, 4, 5, 6, 7. Again in pass 2, I start from the second position because first element is fixed here. We find out what is the first element, minimum element, after doing the comparison with all the element in pass 1. Now I start from the second element. So we will do the same thing. We are supposing minimum as 2. So we are comparing second with third, second with fourth. So now second with fourth, because fourth element is less and second element is more. And then we'll compare fourth element with fifth, sixth, seventh, all are greater. So in the second pass we are swapping fourth with second. So what will be the array? 5, then 15, then 41, swapping second and fourth, 24, then 82, then 91, then 75. Now we will go to pass 3, means I is equal to 3, and we are supposing minimum start from third position. So 1, 2, 3, 4, 5, 6, 7. Third to fourth, so fourth is minimum, so this will be swap. Then fourth to fifth, 6, 7 all are greater, so fourth. So third and fourth will get swap. So what do you write? 5, 15, 24, 41, 82, 91, 75. Now we will reach to pass 4. So I is equal to 4. So minimum we are thinking that it start from 4. So 1, 2, 3, 4, 5, 6, 7. So 4 to 5 we are doing comparison. All are greater. 4, 6, 4, 7. So no change in pass 4. Now we will go to pass 5 when I is equal to 5, and we are supposing minimum element as 5. So 5. So we are comparing with 5 to 6. It is not it is greater, and 5 to 7, then it is less. So 5 replaced by 7. So what will be the element? 5, 15, 24, 41, and 5 and 7 will be swapped. So 75, 91 and 82. Now pass 6 will come. So I is equal to 6 and we are supposing minimum is equal to 6. So 1, 2, 3, 4, 5, 6 and 7. So we are doing comparison. So here we can simply say that 6 is greater, 7 is less. So 6 replaced by 7. So 5, 15, 24, 41, 75, 82, 91. Now all elements are over. 2, 3, 4, 5, 6, 7. Now our selection sort is completed because total how many passes can be possible? Total how many elements are there? 7. So total n minus 1 passes will be possible. So 6 passes are possible. So our selection sort is completed. So we can say simply selection sort contain n minus 1 passes, and every pass required maximum n comparison. As we have seen in our first pass, we need n comparison. We compare first element with all the elements, so maximum n comparison are possible. And in every pass of selection sort, one swap occur. One swap occur every time we are swapping element, whatever minimum element we get. So we can say total n minus 1 swap, because in every pass, and pass are n minus 1, so swap will be n minus 1. So we can say time complexity of selection sort will be comparison plus swap. As we have known that every pass require maximum n comparison, and total time, so we can simply say n minus 1. Total n minus 1 passes, and every pass required n comparison, so n into n minus 1. So comparison are n minus 1, and swap are n minus 1. So we can say simply order of n square. And space complexity is equal to n plus constant total number of element, and there is no stack, so constant. So total number of elements are n, so total space complexity is order of n. So time complexity is order of n square, and space complexity is order of n for the selection sort.